so they're going to be watching it. Not today, but... All right. 3-1. So remember from chapter 1 when we came to the square root of negative... We came to the square root of negative numbers. We said for right now we're going to just identify that as not real and move on. Now we are going to dive into not real means it's imaginary, and now we're going to actually work with imaginary numbers. Why do we need imaginary numbers? You might be thinking, okay, first of all, if you can't take the square root of a negative, then why did they create the math so you can? Here's why. Look at this slide right here. With me? This parabola is above the x-axis opening up, right? So, is it going to cross the x-axis? No. So what are these solutions? Well, I can't tell you visually because it's not going to cross. So that's why the math is necessary in order to be able to find the solutions to something like this when it's not crossing the x-axis at all. This is an example of when the solutions to a quadratic are imaginary, because it's not touching the actual x-axis with the real numbers. It is, in fact, only involving imaginary numbers. Here's how you actually get it. Take that. That is y equals x squared plus 1, right? Write it right here. Let's solve it for x. So what would I do? I would subtract the 1. We are assuming, hold on, we're assuming that we can solve it, right? Let's pretend like we don't have the visual. If I said, hey, where does this cross the x-axis? What are the solutions? You would replace y with 0, and then you would solve. So I'm going to subtract 1, and then how do I undo squared? I square root. So I'm going to square root both sides. And the square root of negative 1 could come from potentially positive square root negative 1 or negative square root negative 1. Now, you can't take the square root of a negative 1. Can't take the square root of negatives at all, and that's because the square root is saying that some number times itself yielded negative 1. There's no way to multiply a number by itself and get negative. It's not possible, because it's either a positive times a positive, which is positive, or it's a negative times a negative, which is positive. There's no way to multiply something by itself and get a negative. It's not possible. They have to have opposite signs. Enter complex numbers. Go to this slide. Do you need a note sheet? Enter this slide right here. Some mathematician somewhere down the road said, hey, that's not enough. We need to be able to work with these numbers, even if they're imaginary. Enter I. I stands for the value, the square root of negative 1. You should. This is from Algebra 2. You need to have that memorized. I is the square root of negative 1. Memorize it. Now, looking at that equation, if I square both sides, that's an equation. I can do whatever I want, right? I could add 5 to both sides. It's not going to be pretty, but I could. Well, what if I square both sides? Then I would have I squared, and what would happen on the right?
Square root would go away.
The square and the square root would cancel, and I'd be left with negative 1, which is exactly why you need to memorize that I squared is negative 1. I squared is negative 1. Maybe remember this. I is the square root of negative 1, and if I go in and square the whole thing, I end up with I squared equals negative 1, because this is going to cancel the radical. Okay? You've got to have those memorized to make your life easier with where we're going with this. All right. So how's this going to help me? Well, look down here at these examples. We're going to break these down using I and simplest radical form. I do not want you typing these in your calculator and telling me the decimal. That is the lazy way out. I want you to reduce them by keeping them as radicals and pulling the negative out as an I. So we have the square root of -7. We're going to break this down. Do you recall from Algebra 1?
No.
Let's see, I know, hold on. I'll go right here. Recall, ... the square root of 8. 8 is not perfect. What perfect square goes into 8? 4. How many times?
2.
Do you remember doing kind of like a factor tree?
Yeah.
And then you evaluate the perfect one, and that ends up being 2 square root 2? Oh yeah, we did it in, was it chapter R? We've done it a couple of times. That is coming into play here. Now there's nothing that goes into 7, it's prime. But I can pull a -1 out. So watch how I do this. You don't have to do this every time. I'm just showing you on the first one. -1 times +7 is -7, right? Yeah. Okay, and we just were assigned a variable for the square root of -1. It's what?
I.
So now I have the square root of 7. Technically, the I is supposed to go on the end. I cannot stand that because some people's radicals look too long and then it looks like the I is up underneath, and it'll never be that way. So while this is the way my math lab wants it, you are going, I'm going to draw a slash. You're going to see me write it like this the majority of the time. That's the way I write it. And a lot of math teachers write it that way. And it's for that very reason that I just mentioned. They want the I after the number, which means you're going to have to hit that arrow to the right to come out of the radical. I know. Sorry. It's stupid. It is stupid. I agree. Yeah. You got me. Yeah. Okay, let's look at the next one. The square root of -16. 16 is pretty. It's a perfect square. It's 4, but because it's negative, then it would be 4i. Now, we're not solving here. We're just breaking these down. If we're not solving, we don't have to worry about the whole positive, negative symbol in the front. When you're solving, you have to account for both scenarios. When you're just looking at something and cleaning it up, you can just assume it's the positive. C is a trick. What's the trick?
It's going to be -I.
There's a negative on the outside of the square root of -13. So the negative here comes down. This becomes what?
I.
There's an I that I always like to say, pull the negative out as the I and then make it positive. That's what I do. I don't write the square root of -1 once I understand it. I just write, it comes out as an I. All right, D. So this negative comes down. This is going to be an I, but it's perfect, so it's going to be 8i. And it has the negative in the front, so it's -8i. Now, the next one is not perfect. Maybe you need a refresher on your perfect squares. There's a perfect place to put them. No pun intended, right here. We're going to put our perfect squares here, just in case you need a reminder. Remember to get your list of perfect squares. All you have to do is count. 1 squared, 2 squared, 3 squared, all the way up to about 15 squared. So make that list here. Okay, so now what I want you to do is to look at 48 and find the perfect square that goes into it. We're going to break the square root of negative 48 down. Okay, 4 does work. I'm glad you picked 4. I'm going to tell you to pick a different one, and then I'm going to show you why. 16 is the winner. Can anyone tell me why 16 is optimal? It leaves you with 3. Well, it leaves you what? With 3. It leaves you with times 3. What does 4 leave you with? 4 times 12. And what goes into 12?
4 and 3.
Another 4. So there's the problem. So when you're doing this, there is a smarter, not harder route, and that is to pick the largest perfect square that works. If you are rusty on this, here's a technique. Take the number, find where it falls in the list. So in this case, it would be right here, right? And work your way down instead of working your way up. Because then you will always hit the highest perfect square, and you'll never run into that, ooh, I could have picked a better number. Okay? All right, so we're going to take, and I'm going to go ahead and pull the negative out as an I. I like to work underneath it so you can kind of see the linear thought process. So this is actually the square root of just 48, right? And then we said what goes into 48? 16 goes 3 times. What's the square root of 16? 4. Now don't write I for root 3. You need to write 4I root 3. Now on my math lab it would be 4 root 3, arrow out, I.
Of course it is.
I know. I'll put it right here in the middle. It would be 4 root 3, be careful, I. They want the number by itself and an I on the end. Oh, yeah, it's just, especially because when we're grading papers that you've written by hand, people's radicals tend to look like it's over the I, and they might not have meant it to be, or they might have. So let me show you. Although I explained it, but let me show you what we say. We said, what if you pick 4? Then you would have 12. This would be, I'll pull the negative out. Okay. Alright, this would be, and then what happens here? You see what I'm doing?
Then you just multiply the
This
2's together.
ends up coming down. This is still down here. This is here. This is here. And good Lord, I'm finally there, right? When if I had just picked 16, I'd have been there in 2 steps.
Let's see.
So that's the difference.
I had to do that way because I don't know. I kind of just like forgot my calculator half the time, so I just went with what I knew.
This is if you had picked 4, you would have had this long of a problem. You'll still get the right answer. It's going to take you more steps. And there's a potential chance that you're going to think the answer stops here when it actually doesn't. So, so try to avoid that mistake.
Correct.
Hold on. Sorry, hold on. All right. Okay. Go to O.
I think now's the perfect time for a bathroom break.
He said,
Why didn't I try to convince? Why didn't I try to convince Miss Holcombe that I had Tourette's when I first came into class? Fun.
Yes.
No.
All right. Look at this slide. What is the number called if an I is involved?
A complex.
Called a complex number. Okay? How do you remember this? Well, it's complicated. It's complicated because it has real and imaginary parts. So, like I've said before, mathematicians name things in a way to help you remember kind of the concept behind it. Complex numbers, it's complex, they're complicated, because there's a real number, there's an imaginary number. Those are not like terms at all. You can't be in both, although some people think they are. But what does it look like? In standard form, it looks like this. The real number comes first, the imaginary number comes second. That's called standard form. Now, if the real number is 0, which means there's not one, right? Then it would be considered pure imaginary. If the real number is anything but 0, then it's considered complex. Go to the next slide. Now what we're going to do, the purpose of this section is to learn how to add, subtract, multiply, divide complex numbers. Adding and Adding and subtracting complex numbers is exactly like adding and subtracting polynomials. Think of the I as a variable like x. If it does not have an I, you cannot combine it with it. It just shoves up next to it. So look at these questions here. It says add or subtract and simplify each of the following. Let me say that people get these wrong because they see parentheses and they start multiplying. They think, so I'm going to write, watch out. They think, for instance, like x plus 2 times 3x minus 1. They think it's like that, and you start first, outer, inner, last, just because they see 2 sets of parentheses. Please don't miss the easy problems that are in here for a reason. This is simply saying to do what? Add them. This is simply saying to do what? Subtract them. There is no multiplying here at all. All right, so let's add them. It helps to look at the numbers and think to yourself, real to real, imaginary to imaginary. 8 plus 3. 6i plus 2i. Do we need to put it in parentheses? Nope.
That's pretty simple.
It's very simple, and people miss these because they start multiplying. And I can't say, no, it wasn't multiply, because then that's me calling attention to the mistake that was made of not reading the problem correctly. All right, so that's the answer here. Now, this one, you do have to distribute the There you go. You got to watch out with that GPS.
Oh, dang it.
Mine did not work on the way to Florida, and I definitely hit a Costco-sized Rubbermaid bin wide open. It's great. The car in front of me swerved at the last minute, so then when I swerved at the last minute, I hit it wide open on the front right side of my car. Busted everywhere. A little bit of lingerie went flying. And, so my mom texted my husband to say,
Miss Holcombe, what?
Back up. I know. It wasn't mine. It was the.
Oh, I thought it was falling out of your car.
What did you say?
Picture it. I'm driving and I hit a Rubbermaid.
You worded it so wrong.
Rubbermaid container, and it busted. Whoever it belonged to was storing clothes and lingerie, and it went flying on the interstate.
You'd think they'd stop for that.
Giant, you would think. Well, you would think I would stop after I hit something. And I didn't. I just kept driving because I'm like, I don't hear anything. And my husband called because my mom texted him. And he was like, pull over and check your car. And sure enough, the front end of my car had the giant corner of the Rubbermaid container stuck in it, hanging out.
And a piece of lingerie was actually.
There was no lingerie in it,
Yeah.
but it was funny because I'm one of those people driving down the road with something hanging out of your car, and I had no clue. I was just driving.
You're like, time to go busy.
Yeah. It busted the front end of my car, so I have a nice insurance claim. So it was not on my Waze app though, so watch out, be careful. Sometimes things are on the road.
That wouldn't be
Yeah.
Object on the road ahead.
And it wasn't there when I left either, because I busted it wide open like
What voice do you have on your waist?
British.
Really?
Yeah.
I'll be dying.
I love British.
Although my Siri is Australian.
Car on shoulder
My
ahead.
Siri is Irish.
My
I don't have
Of
one.
course, it's your shoulder head.
That's mean.
I didn't hear that. All right, we are recording. I have distributed the negative. We've distributed the negative, so we're not going to hit it wide open.
She was hitting something her
Keep
way.
up.
And then I was in my lane. I was definitely in my lane.
You said you swerved.
Out of line. I had to
You swerved
swerve.
out of your lane.
It was in my lane.
When there are barriers in your lane, you just gotta keep trucking.
I did. Busted the whole
See,
thing.
that's that be on
What
an
happens when
Instagram
you try to
reel.
get out of your lane?
That's
So you
true.
learned your lesson.
I'm just glad there wasn't a car in the other lane, because I was definitely, my kids were.
Yeah, let me see him before you send it.
All right. Did you get this?
Yes.
Yep.
I don't think we need to practice any more of those. There's one of each. They don't get any more complicated than that. We are, let's see. I was going to say we're only dealing with integers, but I'm trying to remember if there was some decimals. I won't say there's no decimals because there's a chance there could be, but it's mostly integer numbers, pretty numbers. All right, go to this slide. Yeah. All right. Look right here. I need to lay something out for you. And that is, you will notice, hold on, you're not responsible for writing all this down. I need to explain it to you. Okay, so what's the purpose of what's up here at the top?
To show us what's right.
It's to show you the two techniques that people tend to use in solving or simplifying radical expressions with complex numbers. Let's direct your attention to the red X. This example is incorrect, and the reason why, if you look at it, you're probably going to argue with me and say, no, that makes sense, that it should be right. This is root -2 times root -5. We've learned you can multiply radicals together freely. They don't have to be like terms. So radical times radical, this wrong way multiplies those numbers to get positive 10. But the problem is it never mentioned I. And it definitely started imaginary. So that's why this is wrong. Okay? So try not to do that. You need to manipulate the radicals with immediately addressing the I part. Then clean it up. Okay? So looking up here, what they did was they pulled the I out of each one of them. I and I. And then they multiplied the 2 times the 5. I times I is I squared. Remember from the very beginning we said to memorize I squared is -1. So the correct answer is the negative square root 10. Now you might be thinking, well, it doesn't have an I in it either, but it did right here. That's what makes this correct. This never mentioned I at all, which is why it's wrong. Okay? So be careful there. We'll make a note. This mentions I. That's why that one's correct. Okay, so now let's multiply. Your multiplication rules are the exact same here. Nothing new. You just need to remember, I'm going to say, recall, I squared is -1, because that is going to play a role.
And that's why it worked in that first one.
Correct. All right, we have the square root of -16 times the square root of -25. address the I first. Both of these are perfect. So this ends up being 4I. This ends up being 5I. I get 20I squared. What is I squared? It's negative 1. So this is the same thing as 20 times negative 1, which is negative 20. Alright, look at the next one. Remember when you were multiplying a polynomial, a binomial times a binomial? We said there's 2 ways to do it. I said I don't like the FOIL method because it doesn't work if it's a binomial times a trinomial, which this is not. So if you know when not to use the FOIL method, I'm fine with you using it. It's okay when it's a bi times a bi. It is not okay when it's a binomial times a trinomial. Not okay. Doesn't work. Or you can do that whole beat repeat thing. Remember that split repeat? You could do that too. It's up to you. I'll refresh you on the split repeat because I know everybody knows the full method. Split repeat is the distribution method which works every time, no matter what it is. You split this apart, 1 beep plus 2I beep, and then you repeat the second set. And then now what you've just done is rearranged it to a monomial times a binomial, which is a lot easier. And now we multiply. So we have 1 times 1, 1 times 3I, 2I times 1, 2I times 3I. You're going to get an I squared. I want you to start doing something every time you clean these up. Take a pencil. I want you to circle I squared, the number and the sign. There's a reason I want you to circle the sign.
If it's negative, then it'll become positive.
It's always going to change the sign of the number it's attached to. So instead of taking more time to say 6 times negative 1 is negative 6, you can just look at it and say, okay, this is fixing to have a sign change. And I'm going to drop the I squared once I've changed the sign. So this is going to become minus 6. Do you see that? Now I can go and clean things up, ignoring what's circled because I've just addressed it. Does that make sense? So combine like terms. We have 1 minus 6. 3I plus 2I. And that's the answer. Real number, standard form. Real number first, I second. That's the technically correct way to answer it.
Is that my math?
That one, honestly, and I understand that one. I don't know. I guess after you teach it so many years, it looks awkward to put the I term first. So now I'm accustomed to it. It should work. It should work. What? Yeah. It should work out that way anyways. Very rarely should the I term be in the front unless you've moved it to the front already. Let's look at the next one. Please don't write 9 plus 49I squared. There's a middle term there. This means take the binomial and square it, which means write it twice, which means it's the same format as what we just did. There's a middle term. Now I'm going to do first, outer, inner, last. So first times first, outer, inner. Oh, the I tricked my mind into thinking I wrote the 1. Outer, inner, last. You will notice notice that I make my eye have like a little curve at the bottom so that I don't accidentally look at it and think it is a 1. Okay, and then I told you, circle the I squared, the number, and its sign, and what does it become? Becomes the opposite, and you drop the I squared, right? So now I have 9 minus 49. Go with me? And then these are the same term, same sign. Remember adding and subtracting like polynomials, so there's no exponent there.
This is fun.
I actually like working with complex numbers. Some people can't stand them, but to me,
This is better than last.
Yeah, so far.
well, last unit was domain and range and intervals and stuff like that, and that a lot of people don't like that.
Last year,
Why don't you tell me how you really feel?
I hated this.
Y'all make me feel so special about
Actually,
myself.
not last year. 2.2.
You don't make me regret becoming a teacher at all.
Anybody know?
Oh, I'm sure every single one of us experiences it. My master's is in just math, so I had an exit strategy.
What?
I have yet to exit. Because on the good days, it's just so good, and I love the kids, but politics and the people, I can't stand it.
Oh, yeah.
Oh, yeah.
Oh, I'm drinking my water.
All right. You're going to love this. Look at this.
That looks
I
stupid.
can't stand this, but you're going to love it. You ready? You can do
What?
it.
That doesn't make sense.
Yeah, Mission.
There's a calculator.
Please go to
Oh, I am
mode.
this. Never mind.
Mode.
Moe's. Welcome to Moe's.
Mode.
Mode. Mode.
We're gonna put it on
Because of
engineering.
They put it on engineering mode.
Put you on the ASVAB again.
What about scientific?
Hold on.
Why section?
Okay.
That's what it says in the book.
Please scroll down to where it says real. Notice to the right it says A plus BI.
Hit enter.
Hit enter.
Enter.
Then hit clear to get out.
Now you can do it.
Now your calculator will answer in complex number form. Now there's a limitation, so this is great. This is wonderful, right? Anyway, I can't stand it because I wish you knew how to do it by yourself without a calculator, although it's there, so we're going to embrace it. But mode, and then it's where it says A plus BI. And that's what you would change it to.
Mine works.
How do I put I in my calculator?
There's an I.
Where?
When I was in
Oh, it's right here.
high
It's on
school,
dot.
we were
No.
not allowed to use the graphing
It's
It's
on
like
the
a
decimal
it's the
point.
special
It's
I on the
seven
dot.
set periods. So year-long math.
1
And so the
plus
first
2.
semester, no graphing calculators. And then the second semester, we went back and learned all the shortcuts. And I'm like, yeah. But I get it. So it will compute operations with complex numbers. However, and I need you to put this on here, but it won't do this. It will not take the square root of a negative number and generate it as a complex number. It will just give you an error. Now, why will it not do that if it will compute complex number operations? I have no clue. It cannot make the connection from, like, I don't want to call this a real number, but I guess
It gave me an I, but it's wrong. It's 4.58 something.
yeah, it won't break the radical down for you. So you do have to know how to do that. All right, now look at this. When you first look at this, stay with me. When you first look at this, you're probably thinking, what in the world? This is one of those questions where when I show you the pattern, you are going to realize how easy it is, and then you could throw it in front of a friend that you wanted to impress and be like, do you know I to the 348th power? And then when they say, I have no clue what you just said, you could do it for them.
I would
And
never
you're
ask
gonna look like
anybody
You
that.
want to ask someone that?
Yeah, don't do that.
No.
Oh.
Why would I do
I
that?
have t-shirts.
You and Mr. Ward probably like, what about I to the 4,457?
Negative.
That's
All right.
so
She
high.
doesn't like Mr. Warren.
Look right here.
Yeah,
So
she
please, please, please look. Recall, I is the square root of -1.
We had to
right?
write these down on a chart last year. Algebra
Yeah,
2.
you do. This is an understood 1 right here.
Oh my legs.
I squared is -1. We've already learned this.
What time is it, dog?
I cubed. Let me show you how they got it. What they've done is taken and applied the rules of exponents. I cubed can be written as I squared times I. What is I squared? And -1 times I is -I. I to the 4th power can be rewritten as I squared times I squared, or I squared squared. It's a little redundant. But anyways, what is I squared? -1. And if I square that, I get 1. Now look right here, I to the 5th. They rewrote it as I to the 4th times I. We already found I to the 4th to be what? 1. So 1 times I is I. Look, I to the 6th. They rewrote it as I squared cubed. I squared is -1. If I cube that, I end up with -1. Do you see a pattern? Look at the red numbers. Well, that's not red, but -1, -I, 1, I. -1, -I, 1, I. Then there's a pattern. It's every 4, there's a pattern. Maybe. Alright, so right here. This is the pattern. I to the 1st power is I. I squared is -1. I cubed is -I. I to the 4th is 1. Now, the good news is you don't necessarily have to memorize that per se, but you can generate that list, and then I want you to think of bless you. I want you to think of quarters. Here's why I want you to think of quarters. You're going to simplify these I to the powers down here. You're going to divide the exponent by 4 and focus on the decimal. Divide the exponent by 4 and focus on the decimal. The decimal, if you recall when you first learned about division, is what we used to call the remainder. Remember that?
Yep.
So for instance, 9 divided by 4. Well, it goes 2 times for sure. But 2 times 4 is 8, so there's a remainder of 1, or 0.25. That's why I want you to think of quarters. When you divide by 4, the decimals are 0.0, 0.25, 0.5, 0.75 because of quarters. Because you just divided by 4. So for instance, 37 divided by 4 is 9.25. How many quarters is that? So 1 remainder, and then what you do is you calibrate it to, instead of I to the 37th power, you do I to the 1st power, because it was a remainder of 1. What is I to the 1st? It's I.
Well, this was a fun class.
I actually didn't hate that. Very cool.